So look at this problem right here. We have used the given zero to find the remaining zeros of the function. So that's how we have negative 3i. That means there's also got to be a 3i present. So again, one way to do this is we can actually use the apps button on the calculator and go down to number 7 and the root finder. Notice how this is a degree 3. We already got a plus bi lit. This all looks good. Go next. If I type in the polynomial, I already got a 1. Minus looks good. That's got to be a 7. Hit enter. And then a plus sign actually there. Hit enter. A 9. Hit enter. And that's got to be a minus. Hit enter. And a 63. Again, you may have something a little bit easier. A sub 3 just stands for the coefficient of the x cubed, which would be 1. A sub 2 would be the negative 7. A sub 1 would be the 9. And a sub 0 would be the negative 63. So we got that all entered. Looks good. So if I hit the solve button, notice how it gives me the remaining zeros. So negative 3i was already there. So the remaining zeros would be the 7 and the 3i. So again, if I want to do this algebraically, if we have x equals 3i and x equals negative 3i, what we have is x minus 3i is a factor. And we also have x plus 3i is a factor. If I multiply those together, so if I have x minus 3i times x plus 3i, if I multiply those together, I have, again, since those are conjugates, all you got to do is multiply the first terms and the last terms together. That's going to be x times x is going to be x squared. Negative 3i times 3i is going to be negative 9i squared. But remember, I squared is a negative 1, which means this turns into a plus 9. So what we have then is x squared plus 9. So what I can do is, since I can't use synthetic division because of this x squared, I can use long division and divide x squared plus 9 into this x cubed minus 7x squared plus 9x minus 63. So again, we're trying to figure out in long division, what times x squared is x cubed? Well, we need an x there. X times x squared would be x cubed. X times 9 would be a positive 9x. So remember, our next move is to subtract. So these signs have to change. When they change, the x cubes drop out, and we have this negative 16. Actually, this x squared would stay put, wouldn't it? So I've got those not in the right place. Try that again. Let's line them up correctly. So x times x squared is x cubed, and x times 9 is 9x, which goes over here, actually. So when I change the signs, that's the same changes, and that changes. And when I add them together, the x cubes drop out. The negative 7x squared comes into play. And the 9x's and the negative 9x drop out. We have this minus the 63 comes into play. So our next move is, what times x squared gives me negative 7x squared? Well, that would have to be a negative 7. So negative 7 times x squared is negative 7x squared. And negative 7 times 9 would be a negative 63. So what happens is, when we subtract, we just change the signs and add. So it turns into a positive. That turns into a positive. So notice how when you add, these are opposites and these are opposites. So that just turns into remainder 0. So x minus 7 is the remaining factor. So with x minus 7, we just set that equal to 0 and solve for x, and we get x equals 7, and that would be the other 0. We also could maybe, if you wanted to use the graphing tools, you could try it that way. So I have to quit this here. So if I hit y equals, if I clear that out, you could put x cubed into the calculator, minus 7x squared plus 9x minus 63. So if I go to the table, I'm looking for a 0 in the y area. So notice that scrolling up through there, I do see that 7 is a 0, so I also can pick up on that one as well. So notice how I could have found, if this is negative 3i, I have the 3i, and then the calculator actually found me another 0 there, which means I would not have had to do long division either. So notice how there, we can use the apps button. We also have the table and the calculator, and we also have synthetic division and quadratic formula types of things, but this one actually turned out long division instead. So again, feel free to watch this video to kind of pick up on those strategies.